students, this is Indrani ma'am from SIRP Rasayan. In this lecture, I will explain following reactions. All are dehydration reactions. Before starting, I will explain some important points on dehydration of alcohols with mineral acids. Now see, dehydration means removal of water. Reagents used are concentrated sulfuric acid or phosphoric acid. These are mineral acids. By dehydration of alcohol, alkene is generated, and here major product is Sedgep's product. Means more substituted alkene is the major product. Another important point you have to remember, the reaction takes place via carbocation intermediate. So if possible, there is rearrangement of carbocation. While writing the product, you have to think about it. Now see, this is primary alcohol, this is secondary alcohol, this is tertiary alcohol. If you heat these alcohols in presence of mineral acids, what will happen? Removal of water, means dehydration will take place. So from here OH will go and H will go. From here OH and H will go. Both the H's are symmetrical here. From here OH and here H will go, and we will get from here ethene, from here propene, and from here you have to numbering like this way. So it is 2-methyl propene we will get. Now see, here we are using concentrated H2SO4 for primary alcohol, and then we are using milder conditions for secondary and tertiary alcohols. Here also higher amount of heat we are using, but here comparatively lower amount of heat is required. So we can say secondary and tertiary alcohols are dehydrated under milder conditions, because these reactions, as I told you, takes place via carbocation intermediate, and you know tertiary carbocation is more stable than secondary than primary. Now see, dehydration of alcohol is beta elimination, because with respect to this leaving group, means OH, this carbon is alpha, this carbon is beta. Hydrogen attached to that carbon is called beta hydrogen. So beta hydrogen is eliminated. So this is called beta elimination reaction. Now see the first reaction. On the arrow it is written H plus heating. So what will happen? Here alcoholic oxygen is having lone pair of electron. It will be donated to H plus. So we will get this is protonated alcohol. Now removal of water will take place. We will get so here another hydrogen is there. To satisfy the fourth valency of this carbon, you have to write here one hydrogen. Now by removal of water, you will get here carbocation. This carbocation is secondary carbocation, because this carbon is attached with 2 carbon atoms, and obviously here also there is one hydrogen atom to satisfy the tetravalency of carbon. Now see, since it is beta elimination, so with respect to this OH, this carbon is alpha and this carbon is beta. So here 2 beta hydrogens are there. Here beta hydrogens are there. So what is the main trick? Where there is positive charge, adjacent to that positive charge, if any carbon atom is there where one hydrogen atom is also attached, that hydrogen atom can go. So this hydrogen, this beta hydrogen can go by removal of H plus minus H plus, means removal of H plus, we will get here double bond. Here CH3, this alkene. Now see, since it is carbocation, so here what can happen? Rearrangement of carbocation can take place to form more stable carbocation. So this hydrogen with its bonding electrons can migrate from here to this positive center, and due to 1-2 hydride shift, what we will get? H minus will come here. So we will get here one positive charge. And this is tertiary carbocation. Since with this carbon, 3 carbon atoms are attached. So this is more stable. So as I told you, where there is carbocation, adjacent to that carbocation, if any carbon is there, see with that carbon any hydrogen is attached or not. So here 2 hydrogens are attached because already 1 hydrogen was here and 1 hydrogen is migrated. So here 2 hydrogens are there. So here this hydrogen you can eliminate and we can get this product, this alkene, by removal of this H plus. Another thing what you can do with respect to this positive charge, adjacent carbon atom is there, with that carbon hydrogen is attached, so that hydrogen can be removed as H plus and we can get this product. Now we can see 3 possibilities are there. Here whatever alkene we got, it is disubstituted, means with that alkene 2 carbon atoms are here attached. Here with this alkene 3 carbon atoms are attached. With this alkene here it is trisubstituted. Here this alkene is disubstituted because 2 hydrogen atoms of the alkene is substituted by these groups. So according to set-Zeb rule, more substituted alkene is the major product. So this is your major product. So on the arrow only you have to mention here the major product, because question was write the major product of the following dehydration reaction. The first reaction I explained all the product. For the next 4 reactions I will explain the major product. Now for second reaction, what is the major product? At the first step, this lone pair of oxygen will be donated to H plus. We will get protonated alcohol, CH2 OH2 plus. Then what will happen? Removal of water will take place. This bond will cleave, and here on the arrow you can write removal of water means minus water. So we are getting this carbocation. Now see, to satisfy the tetravalency of carbon, here 1, 2, 3, so another hydrogen should be there. So this is primary carbocation, 1 degree carbocation, because with this carbon another carbon is attached. So what we can do, we have to check whether any more stable carbocation generated by carbocation rearrangement. So by 1,2 hydride shift, this hydrogen, if it will go with its bonding electron here, it will form what? It will form, if it will go here, it will form CH3 and here positive charge. Why here positive charge? Because these 2 electrons are coming here. So this carbon is losing its electron. So here positive charge. So we are getting here tertiary carbocation because this carbon is attached with 3 carbon atoms. Now what will happen? Which H plus will be eliminated adjacent to this positive charge. Here this is adjacent carbon atom of this positively charged carbon. So this hydrogen atom can go. Removal of this H plus will give this product. Another option is there. With respect to this carbocation, adjacent carbon atom is this and this also. Here 2 hydrogens are attached. These 2 are symmetrical position, so any H plus can go. If it will go, what we will get? Minus H plus, we will get here double bond, here CH3. So between these two, which one is major? This is tri-substituted and this is di-substituted. Because this is tri-substituted, this is more stable, so this is major alkene, and this is di-substituted, so this is minor product, but major you have to mention here. Now see third reaction. This is alcohol. On the arrow H plus, heat is written, so you have to think about dehydration of alcohol. Same way you have to think, this will be donated to H plus, we will get then this bond will break to neutralize this, and we will get this carbocation. Now see here, adjacent to this carbocation there is one carbon, here there is another carbon, but here no hydrogen is there. You can see here two hydrogens are there. Now this carbocation is 2-degree carbocation. If you migrate this hydrogen with its bonding electron, what will happen? Here hydrogen will go and we will get this structure. Already one hydrogen is here to satisfy the valency of carbon, tetravalency of carbon. So here also we are getting secondary carbocation. So there is no meaning for rearrangement. Then what we have to think? If you migrate this bond, just take out this bond from this carbon and migrate it here at this positively charged center with the bonding electrons. So what will happen? Just take out this bond and migrate it here with its bonding electron. So carbocation rearrangement will take place. What we will get? Since we are taking out this bond from here to here, here we are getting one positive charge. So now see, this carbocation is tertiary. So we are getting this more stable carbocation. Then from adjacent carbon atom, H plus will go and we will get this alkene as major product, because this is tetra substituted. This is the major product, or this product you can write like this way also. One 6-membered ring is fused with another 6-membered ring and here double bond is there. So in any way you can write the product. Now see in the next example, here OH is there, 2 double bonds are there, 2 methyl groups are there. H plus, heat. So obviously first you will get protonated alcohol. Mechanism I am not showing here, OH2 plus and here 2 methyl groups. Then what we have to do? We have to eliminate this water to neutralize the positive charge. Minus water on the arrow you can write. We are getting this carbocation. Now see, to satisfy the valency of carbon, here one hydrogen you have to write. So one hydrogen is already there here. Here one hydrogen is there. So this carbocation is bonded with 2 more carbon atoms. Therefore it is secondary. So if this methyl, here this is methyl group, this is also methyl group, any one methyl group you can migrate with its bonding electron to adjacent carbocation. So what will happen? Because here no hydrogens are there, methyl group is there, it can also migrate. So what product you will get? If it will migrate, here one hydrogen, here CH3, from where migration of group will take place, 1, 2, CH3 minus shift is taking place. So due to carbocation rearrangement, what you are getting here? Plus. from where hydride or CH3 minus will migrate. At that carbon, just write positive charge. Now, this carbocation is what? It is bonded with 3 more carbon atoms, so it is tertiary, it is more stable than secondary carbocation. Then what will happen? Adjacent to that carbon, hydrogen is there. Remove this hydrogen for beta elimination. Minus H plus. You will get this aromatic compound. Now next example, you are having this alcohol on the arrow H plus, heat is written. What you have to do? That lone pair will be donated to H plus, you will get protonated alcohol. Then what you have to do? You have to remove this water to neutralize the positive charge here. What you will get? On the arrow you can write minus water. So we are getting this carbocation. Obviously, to satisfy the valency of carbon, here one hydrogen is there. That hydrogen you can write here for better understanding, and here also valencies of carbon 1, 2, 3 are satisfied. So here one hydrogen is there. Now see, this is secondary carbocation. So you have to see if by rearrangement you can get some more stable carbocation or not. Adjacent to this carbon, this hydrogen is there, so you can migrate this hydrogen with its bonding electron here. So what you will get? You will get this. And from where migration of hydrogen or methyl, all those are taking place, there positive charge you have to write, because this is becoming electron deficient. Now see here, if you check the valency, this carbon is bonded with these 3 carbons, so obviously one hydrogen atom is there. Major product we have to think. So if hydrogen can go from this adjacent carbon or from this adjacent carbon or from this adjacent carbon, these two positions are equivalent. So here if hydrogen will go from here, what you will get? You will get this, means tri-substituted alkene. But if hydrogen will go from here, what we will get? This tetra-substituted, see, tetra-substituted alkene. So this is the major product. This will become in minor amount, but here we don't need this one. Only major I am showing according to the question. So if you like, please subscribe. Thank you for watching.